My name is Akshay Iyengar, and I'm a junior here to present the HDR project. HDR is a technique that allows for multiple snapshots of images in a way that ranges from dark to light contrast. By doing this, photographers can create a better depth and visuals for an image and allow the audience to see more refined details. This technique uses shutter speed time, exposure time, and just images from the exposure to create the final images. As we can see, there will be different ways to implement this on the next slide. For the first part of this assignment, we were tasked to use the mean. Basically, from that, I created an empty HDR image and ran a loop in order to normalize the pixel values across exposures, and then summed those up, and then divided by 16 to get the mean. Similar to this, for the weighted average, I took into account that there could be extreme values. In order to check those, I did a nested for loop in order to figure out the weights for each of those pixel values. After that, I added them across the exposures and normalized it, and then divided by 16 again to get the weighted average. After that, we worked on the median, and with the median, it's a different approach. I created an empty exposure matrix and filled it with the exposure values. From there, I took the pixel values in a nested for loop and checked if they were near 0 or 255, giving them NA values if they were. After that, I also did that same thing with the exposure matrix. Because of this, I was able to take the median of the pixel values itself and the median of the exposures and kind of create the new image. The fourth one was the highest, which is similar to the median. The cool thing about this is you just take the max of the exposures and the max of the pixel values to get normalized to get the image. For the last part of this assignment, I plotted the pixel values versus log exposure using the G-solve inputs, using a lambda of 75 after trial and error. Through that, I was able to solve for a numerator from the G from the color channels and subtracted the log exposures. Using that, I multiplied by the weight, and that was my numerator. My denominator was the sum of the weights. From there, for each color channel, I concatenated them together, and then I exponentiated those values in order to get the final image. So some of the results here, you can see it goes from like worst to best. So the mean isn't that good. But then we see the second one, the weighted average, it kind of shows a little bit more detail. Third one kind of paints a clearer picture, as we can see everything, and there's still faint color on the top. The fourth one kind of tries to correct it, but you can still see there's a little bit of some contrast and dark contrast in some of the parts of the picture. So the thing with this sophisticated method uses a response function with the lambda 75. Basically, we can see that the color on the right is more colorful. You can see the glass looks more clear, and you can see the structure is more refined, but there is still some noise. So challenges for me were realizing that the double inputs wouldn't work in the graph. It was a sophisticated part of the assignment, as I spent some time on that. Also, you have to reshape and kind of take a lot of memory and time using this kind of process with the sophisticated part. And then the cool things about this was that I loved how to create using the median and non-saturated to produce kind of cool results. Also, using the G-solve was kind of cool because I never thought using that kind of function would be able to create such a cool image. But I still had some noise on it. I thought it was awesome that you could use the concept from day one to apply to this kind of project. I kind of see in the future that research with 3D images with HDR would be cool, along with some live Instagram TV feeds using HDR to depict realism. Thank you for your time.